class. Welcome to yet another session of our lessons. Today we shall be treating the concept of position, distance, and displacement. In today's class, like we agreed, position of an object is actually a measurement that is in line, a straight line measurement that has a point of reference. A straight line measurement that if you look at it in terms of a sketch, it will give you either a positive direction value or a negative direction value. So if we look at this point and take this point 0 as our point of reference or the 0 point, if we move to the right, we have a positive distance, and if we move to the left, we have the negative distance. Now, distance here in this case can be looked at. We can project distance in our polar coordinates, or specifically in the Cartesian plane, where we have to have two values, the x values and the y values. Remembering that on the vertical component, we have the positive y, here we have the negative y, and to my left we have the negative x, and then to my right we have the positive x. So that if we have 2 points given to us, let's say we have a value of 5 and 6, what it means is that the first value represents x and the second value represents y. And if a point is located as 5 and 6, it means that on the x-axis it can be located at point 5, and on the y-axis it can be located at point 6. Now, all measurements from the origin to the left gives us negative direction, negative values, while movement to the right gives us the positive values. Now, in locating points, sometimes we may have 2 or 3 points that we need to locate on the polar coordinates or even in the Cartesian plane. Let's take, for example, a point given as point P, which has value of 2 and 3, and then we have another point x, which has value of -1 and -1. These two values we have here can be located on this plane if this is calibrated. Let's assume this is 1 value, this is 2 value, this is 3 value, this is 4 value, positive to the right, and then to the left we have the negative values of -1, -2, -3. Now, when we have this, let's look at the vertical values. We have y positive or positive y, that we have 1, we have 2, we have 3, we have 4. And on the negative axis, we have -1, -2, -3. Now, if we look at this Cartesian plane, we have two positive values, x positive on the horizontal to the right, y positive on the origin to the vertical component, and then the negative component, negative vertical is the -y. Now, if we have to locate these points P and X, we'll say that when X value is 2, the Y value is 3. So we come to the X-axis, look for 2, and on the Y-axis we have 3. So this point P is given as 2 and 3. And on the second value point X means that the first value of x on the horizontal is 1 and on the vertical is -1. So if we look at this x value, this is 1, and on the negative value of y, the vertical, we have -1. So when we trace this and trace this, we have point x here, which is 1 and -1. Now, these two distances can also be calculated by determining their resultant value, where we say that the resultant becomes equal to bracket open x2 minus x1 x minus s2 minus x1 and y2 minus y2, y1 minus y2. So the first p value, that's p value of into 2, and this one is 1. So we have 1 minus 2, which is the second value, -2 for x, and here we have -1 minus 3 for this, if this is our first value and this is our second value. So by this, we can have -1 minus 2 will give us -1, and then this one, minus 1 minus 3 will give us minus 4. So the resultant value for this will now be r is equal to minus 1 minus 4. This becomes the resultant value of these 2 points. Now the next concept we want to quickly look at before we start thinking of solving questions later is the concept of distance. Distance, the concept of distance. Distance is defined as the change in position of an object. Distance is the change in position of an object. Now we can have distance defined as the change in position of an object with time. Distance is a scalar quantity. That means it has magnitude but it does not have direction. And then distance is different from displacement. We're going to explain what displacement is all about. Distance is measured in meters. So we can say that distance represented with letter D, which stands for distance, is measured in meters. Distance is measured in meters. Distance is one of the fundamental quantities measured in meters. We agree that it's a scalar quantity and it's measured in meters. And it also means the change in position of an object between 2 points. Now, the distance of an object is not having a specific direction. The distance of an object's direction varies. And that's why distance as a scalar quantity, it cannot be dependent on direction, but it has value. And so we say it's a scalar quantity. Let's take, for example, the second one called displacement. Displacement also is a distance measured but in a specific direction. Distance measured in a specific direction. So let's take, for example, you are at point A and you want to move to point C, but you decided to move to point B, and when you got to point B, from point B you find your way to point C. The distance covered from A, B, C, the change in position from A to B to C is called distance, while the change in position between A and C is called displacement. And now what this means is that although the object or the body moves from A through B to C, what it actually did was to move between A and C, and the distance in that specific direction gives us displacement. Displacement is a vector quantity because it has value and it has direction. Displacement also is measured in meters, just like distance. Like I said, the difference between the two of them is that one is a scalar quantity and the other is a vector quantity. Scalar for distance, vector for displacement. Is that clear? Now, if that is clear, we shall also move a little further to look at a relationship between time, because we define distance as a change in position between 2 points. And so when we have a distance that is covered and we measure it proportionate to the displacement, it gives us a value that we will appreciate. So if a body is moving in a particular direction, its displacement can be measured. Its displacement can be measured. So let's take, for example, there are 3 pairs of values. Let's look at this example. We want to quickly go back to talk about position. Let's take this question. We have, there are 3 pairs of initials. One is P, X, and the final is Q, X2. First one is X1, the second one is X2. Positions along an X-axis. Now they are given. They say which pair gives a negative displacement. Remember we say when there is a displacement, it has to be to the right will give us positive, to the left will give us a negative value. Now, I said that distance, let me take it again. I said that distance is a scalar quantity while displacement is a vector quantity. So I want us to also understand that when we have these values, what we simply need to do is to find the difference between the two. Delta x, which is equal to P of x minus Q of x. Let's assume that the first and second values are represented with those letters. So if the first point is minus 3 for P, minus 3 for P, and then the Q is 5.